Okay, so we're talking about conditional probability today, and we have a quiz on Thursday. See it in blue there? That's this Thursday. That's like 2 days from now. Okay, so you got some things to know between now and then. We did do some probability before the semester ended, but then we did a week and a half of review for the final, and then we did the final. So it's been 2 weeks since we talked about probability, but you'll be getting it back pretty quick here. All right, first thought, this is a blank page. For those of you that haven't already done this, figure out how to add a blank page to your surface. If you don't know how, ask the kid next to you. This should be in Notarize still. Stay within Notarize and add a page. Tell them what to click first. They click on the side. Then they hit Insert. Insert is lower left-hand corner. Blank page. All right. We're going to do an example of one of those charts. Shh. And for in the future, when I say to put in a blank page, it'll be really easy for you because you'll know where it is and it won't take me explaining it to 4 people. All right. Focus. How many of you are male people who would, if I gave you a choice between a dog and a cat that I was going to give you for free, how many of you, male, female, to take with you to college? My kids are already missing our cat before they even go to college. They're like, I can't believe I'm going to have to live without the cat. They love our cat so much. Anyway, how many of you would pick a male person that would pick a dog if you're going to get a free pet to bring with you to college? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. How many of you, put this down please, write this on your iPad. You're making what's called a contingency table. All right, next. How many of you are male people who would choose a cat? I like cats. 1, 2, 3, 4 male people with a cat. I will tell you the cat people have a lot easier time taking care of that cat because you just, it's a lot easier to take care of them. Dogs are so demanding about having to wake you up in the morning to go out and then need to be walked and then you got to pick up their poop. And okay. Female people would choose a dog. Raise your hand if you're a female dog person. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Female people that would choose a cat. Raise your hand if you're a female person that would choose a cat. We have 0 of those. Interesting. Wow. All right. Now, can you tell how many people there are? Now, it's possible that we would not have, yes, it does say 31 if you add them all up. Could it be possible that somebody didn't raise their hand? Yeah, I suppose, because maybe they're like, I wouldn't take either one. Okay, but we're assuming here that everybody had to pick one or the other. All right, so now, what's the probability that if I picked a random one of you, that you would be a male who likes cats? 4 out of, is it out of 18 or is the 4 out of 31? I said I picked one of you. Then it's out of 31. What if I said out of the girls, what's the probability that I pick a cat person? 0. And that one's going to be the same because 0 out of the girls, which is 13, is pretty much the same as 0 out of 31, right? Either way, it's 0. Okay, how about this? Probability, given it's a boy, that it will be a dog lover. Write it on your iPad. Just write down your answer. Now, if you wrote 14 out of 31, you didn't hear something. What did I say at the beginning? Given. As soon as I say given, then you know how it started. You know I picked only from the boys. Given it was a boy, it had to be 14 out of 18. You get that? All right, those are contingency tables. We did that before break. We also started talking before break about these kind of tables right here. You remember what those are called? No, not really a table. Or a tree. Yes, tree diagrams. But let's go back just a little bit. Here's the main stuff that we cover in this semester. We got probability, linear programming, something that HA9 Regular does not do, only accelerated does that. Exponentials and logs, that's something that you're going to use in pre-calc and in calc. So that's a pretty big topic, important one. Matrices, not that important. It's kind of like a side topic. Sometimes you use it in IB. Other than that, you pretty much do it a little bit here and then a little bit in IB maybe. Loans and investments and sequences, that's a cool one because you use it in real life. If you want to figure out what your payment would be for a car, or what your payment would be for a college loan, or what your payment would be for a house, or what if they charge you a higher interest rate because you have bad credit, or what if they want you to have a 15-year loan instead of a 30-year loan, what would the payments be then? You could figure out all that good financial kind of stuff in that unit, and there'll be a few additional things that we learned too. All right, I want you to get to this page with me right now. Find it. Okay, zoom in. If you haven't already learned to do this, tap on your screen, zoom in so that you can see that chart. Zoom, zoom, zoom so that it looks about as big as you can get it. Okay? All right, now, at the beginning it looks like I have a choice, red, blue, or white. All right, that's because in this bag, this is a classic problem. You're going to see this problem like a ton of times before you graduate. The marbles in a bag problem. You see them on the SAT tests, you see them on the ACT tests, you'll see them on the MCA tests. These are like just important to understand. All right, you pick one marble at a time and choose twice. Here's the thing that people don't get sometimes. I think they think that here's where I choose once and here's where I choose twice. Nope. This first event is my first choice. Over here, this whole set, really complicated looking stuff, that's my second choice. If I was having kids, this would be my first kid and this would be my second kid that I'd had. Okay? You don't have like, I have my son Josh and then my son or my daughter Laura and then my daughter Betsy. It's not, it doesn't go like that. My son was my firstborn and then I had a daughter and then I had another daughter. The events go like that. They're like columns. Okay? Okay, now let me clean up my page a little bit here. What is the probability that both marbles are red? Well, that's really easy, and one of the things I want you to learn how to do is use your highlighter. Grab the highlighter tool. I kind of like mine. It looks a little different, though. And do red, red. Well, that's really easy. It's red and red. That is the branch that happened. There's a lot of different things that could have happened. I could have had red, blue. Could have had red, white. Could have blue, red, blue, 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 white, white, red, white, blue, or white, white. Okay, so there's a lot of things that could have happened. This one has a probability of 1/2 times 1/2, which is what? 1/4. 0.25 chance of that happening. All right, now, second question is significantly harder. Given that the first marble is white, a lot of people go, oh, okay, so you want me to go like this and go white. What's the probability of the second being white also? Oh, white, white, so I go 3/10 times 3/10. That's wrong. Because it said given. You're right. Once it said given that at first marble's white, that means we didn't have a 3 in 10 chance of this. What was the actual chance that it was going to be white? No, not 3/10. 100%. This is a 100% chance. Then this one being white is still a 3 in 10 chance. So now I multiply those two together. 100% times that, which means just that, 3/10. All right, so I don't multiply them. If it says given, you are changing the denominator. Okay, so we got interrupted. We had to fill out a bunch of forms today, one-day thing, so this lesson is going to be way shorter than usual. Moving on to the next kind of problem. What is the probability of 3 kids choosing a dog? All 3 kids. Well, and that's pretty simple. You just have to go up this road right here. Dog, dog, dog. Multiply them all together, and you got your answer. It's much more complicated when it's probability that exactly 2 of the kids choose dogs. All right, then I'm going to show you some of those routes that would work and what to do with them. So let's say we had 2 kids pick a dog this way, that, and then they have to choose a cat. That person had 2 dogs. Here's another option. Don't talk now, please. Could do dog, cat, dog. And then there's one other way. Cat first and then dog, dog. Those are the only options that have 2 dogs. What do I do with them? I multiply them all out. Each run has 3 numbers in it. You multiply them out, and then you add them together. So you go this times this times this, added to this times this times this, added to this times this, for example. All right. That's all the time we have for today. It's a short lesson. We'll have more tomorrow.